Hello guys, welcome back. So here we have another question from GATE 2020 and this is another question on finding the Thevenin equivalent voltage. So we need to find VTH of the network shown below. Okay, so here we have a network. Here if you observe, you have a voltage source of 4 volt and 3 ohm resistor in parallel, 2 ohm resistor in series and a 5 ampere current source and another 3 ohm, and we need to find the VTH across these terminals. And from this first, what can we eliminate? We can eliminate this thing because whatever is the voltage across this is going to be same as the voltage across this, because the current flowing in this is 0, which means the voltage dropped across this is 0. Okay, so let us try to find. So we said we can remove this. So we want this voltage VTH, and here it is 5 ampere. So where will this 5 ampere flow? It cannot flow here because here it is open circuit, so it should flow here, right? So all this 5 ampere will flow here. So what will be the voltage dropped across this? It will be 10 volt, right? So here there is 5 ampere, and here if you see there is 4 volt. So this voltage difference is 4 volt. So if I assume this to be ground or some reference which is 0 volt, so this is 4, and here to here I have a 10 volt drop. So what will be my VTH? My VTH will be 4 volt plus this 10 volt drop, so it is nothing but 14 volt. So this question is very straightforward and very easy to solve. Sometimes you might think too much and complicate it. For example, many people will not know that the current I through this 3 ohm is 0. So only if you start with this, you can next proceed that all this 5 ampere will flow across this 2 ohm. So always when you see this type of open circuit, the current through this resistor or similar element is going to be 0. And another thing here is, if you see this is 5 ampere and this is 4 volt. So what will be the current here? It will be 4 by 3, which is 1.66 ampere. So 5 ampere is coming in, 1.66 is flowing here. So what will be the current here? It will be 3.34, 33 or 34 amp. So if you see, this current is flowing into the positive terminal of 4 volt. So what can you say about this 4 volt voltage source? It is dissipating power. Rather than delivering, it is actually dissipating power. So which guy is the one which is delivering power here? This guy is delivering power here. And the next thing is, if they ask you to find the Thevenin resistance, then what you will do? So in that case, you cannot ignore this 3 ohm. Although it is open circuit, once you put a load, this 3 ohm is going to matter, right? So what is determining this 3 ohm? We already saw this VTH is independent of this 3 ohm. So this 3 ohm is going to come in your RTH. So for this circuit, how will you find the RTH? So first thing we have to do is, we have to short the voltage sources and open our current sources. Then how will this look like? So there is short 3 ohm here, 2 ohm, and again another 3 ohm here. So here, since it is fully resistive network, you can directly find the RTH by simplifying the circuit. So if this and this is in parallel, what will happen? All the current will only flow through this, so this will never come into picture. So you can also assume that this is R equal to 0 and this is some 3 ohm. So with parallel combination of this will anyway come to 0 ohms. So simplifying this, you just get 2 ohm, 3 ohm. So what your RTH is here nothing but 5 ohms. So even though you know the theoretical concepts, you must be careful, and only if you're good at basics, you can ignore such mistakes such as ignoring this 3 ohm whenever required and whenever not required. So okay guys, so here anyway we got the answer as 14 volt, right? So round it off to 2 decimal places, so it is 14.00. So okay guys, that's it from here. Take care, bye bye.